Okay, Michael, so before we get started diving into a particular formalism or framework that I want to talk about that we're going to use for most of this mini course, or at least the first half or so of it, I want to remind everybody what the differences are between the three types of learning that we said we were going to look at over this entire course. Do you recall what they are?
Well, reading them off the slide, supervised, unsupervised, and reinforcement.
That's right. And, again, these things are all strongly related to one another, but it's very useful to think about them as being very separate. So just as a reminder, supervised learning sort of takes the form of function approximation, where you're given a bunch of XY pairs, and your goal is to find the function f that will map some new x to a proper y. You recall that?
Yep.
Unsupervised learning is very similar to supervised learning, except that it turns out that you're given a bunch of x's, and your goal is to find some f that gives you a compact description of the set of x's that you've seen. So we call this clustering or description as opposed to function approximation. And finally, we're getting to reinforcement learning. Now, reinforcement learning is actually a name that means many things in different fields, and here we tend to talk about it in a relatively specific way. And superficially, it looks a lot like supervised learning, in that we're going to be given a string of pairs of data, and we're going to try to learn some function. But in the function approximation case, the supervised learning case, we were given a bunch of x and y pairs. We were asked to learn f. But in reinforcement learning, we're going to be given something totally different. We are instead going to be given x's and z's, and I'll tell you what the x's and the z's stand for in a minute, and then we're going to have to learn some f that is going to generate y's. And so even though it's going to look a lot like function approximation, it's going to turn out that it's going to have a very different character. And that's really what the next few slides and a little bit of discussion is really about, is understanding what that character is. You'll also notice from the title here that I have decision-making and reinforcement learning, and that's because reinforcement learning is one mechanism for doing decision-making. And again, I'll define that in just a second. Okay, so you with me, Michael?
I think so. So should y be circled? Because in some sense, you underlined the things we were given and you circled the things we needed to find. So y is something that we're going to find, right?
Yeah, I suppose so. I like that.
All right, interesting.
Now it's a theta.
It's a y trapped inside of a theta. And it's yelling, y!
I like that. I'm a y trapped in a theta. I could write a book about that. Okay, good. That's a good point, Michael. So before we were effectively trying to learn one thing, and here we're still learning one thing because it's going to produce another thing sort of deterministically, usually. But it's worth pointing out that we are going to be figuring out how to produce both of these things as opposed to being given those things. Good job. Okay, so you ready to move forward, Michael, with an example and a quiz?
Awesome.
Excellent.